Okay, hello. My name is Matthew Knight. It's Monday, the 20th of April, and I'm here today to talk to you about my third order ambisonics live streaming network infrastructure that I've been designing here for my final year project. This is what's potentially going to be the last of a series of vlogs that basically has been talking about the development and how I've got to where I am today now. So today we have the most comprehensive working system possible. There are still a few niggles with the player, but essentially we have a working system, and we can theorize and start to talk about how this system can lead on into potentially becoming a piece of software, maybe even a turnkey piece of hardware that can be used in this new burgeoning age of immersive media to potentially try and capture the market when it comes to new immersive media streaming. And that really what wants to kind of highlight a lot of the things that I'm saying in the report, which hopefully you've read, but also lots of things that have been saying in the new standards that are being developed for this. There's very much a focus with this project on getting the audio correct, and so this is only third order ambisonics, but the vision for the future is much bigger, encompassing all kinds of audio types, including object-based audio and channel-based audio, and just, you know, standard mono sources and so on and so forth. But we won't jump into that too much today. What I want to talk about today is the system that I have here, and then I'm going to run a few tests, and then we can just kind of pull it all together. So what I have is on this machine here, we have the Reaper project that is currently recording. On this machine here we have Open Broadcast Software, or OBS as it's known, and that is currently streaming. And here we have my Linux Ubuntu NGINX RTMP server. That's a bit of a mouthful, that one. So essentially, if we run all the way back round to here, I'm going to explain essentially what is capable with this. So this particular project, or it will be a template that will be submitted with the final submission. It has the capability to take in as many audio sources as you want from a core compliant USB audio interface, and from there it can be spatialized using the stereo encoders that are on the screen, which we'll pop over to in a minute and we'll run through in a bit more detail. It's got lots of test signals in it, so we've got sines, sweeps, noise of both the pink and the white variety. I'll just confirm that. Just the pink variety. And then we've got some pre-recorded content in there, which is used to also test the signal flow. So ideally, we have a few kind of test points here. Now, at the beginning of this video, I would have made a slate, so I've clapped before the video, and that can be used to kind of well, to sync this mic with this video for when I create this vlog, but also to, as we're recording at many stages through here, and it won't be synchronous. There's no way that we can make it synchronous at this stage. That we can then pull all of the artifacts from each of the machines together and line them up, and then we can check that the signal is synchronous. It's not drifting, and it's kind of and it's coming out as it went in, as it would be. So we can just kind of, so some generalized tests to ensure that our signal flow is robust through the broadcast chain. So we have 18 channels of audio coming out of this Reaper project via Dante. That is going via Dante Virtual Sound Card into the Dante VIA on the Windows machine here. The Dante VIA on this machine is coming into OBS, where OBS is muxing that with the VR camera or the 360 camera that you can see here in shot. That then takes this these camera and audio feed, and it muxes them together via the RTMP streaming protocol. So that's the Adobe Real-Time Messenger Protocol. From there, it's sending it down an Ethernet cable. But I mean, essentially, the idea in the long run is for this to this machine here that isn't potentially part of the workflow. It's actually inside a content delivery network, or in a server, residing somewhere else, and it just runs the server blocks. So we've got RTMP contribution coming into our Ubuntu server. So it's actually an NGINX server, which is the server software I'm using. And in here we have an RTMP server block on the NGINX server, or NGINX, should I say. And what that does is that demuxes the RTMP stream and splits that into audio and video feeds, and then it Dash encapsulates these. So that creates 3 types of files. It initially creates a header file. So we have a header file for the audio and a header file for the video, and then it creates chunks at set given times for both the audio and the video. When it's started these 2 processes, we can then create the Dash manifest. Now the Dash manifest is the most important thing here, because that essentially tells the player, so in our case that's host 360, it tells the player exactly what it should be looking for in those headers and chunks. So it says these chunks are 2 seconds long. This is our margin forever. This is where you can find them. This is the number that the chunk starts at, and the whole plethora of other information like color space and frames per second, and audio codec and bit rate and sample rate, and all of the kind of things you would imagine that you could describe a media presentation with can be found inside these manifest files. And this is exactly the core of MPEG Dash, and this is what MPEG OMF expects to build upon, really. So like essentially a lot of what we're kind of delivering doesn't necessarily change, but how we describe it does change, and that allows us to be a lot more flexible with our content. It's a real key point with Dash, and it's how we achieve the adaptive bitrate. So if you have a low speed connection, you get a low bitrate version. If you have a high speed connection, you get a much higher bitrate connection, and everything in between. So that's really key. Now I'm just gonna pop over to here, to the audio machine, and we're going to actually start doing some testing. So as you can see, I just put it up on the screen now. This is the Reaper template that I was talking about, and you can see the stereo encoder front and center of the screen now. That's for this mic that I'm talking into now. The feed that you are now listening to is the binaural feed. So from that we can actually pan the audio around, and I'm going to do that now. So at the moment you will hear the audio at the front of the sound field, and now I'm going to be moving around to the right hand side of the sound field, and now we're going to be moving around to the back of the sound field, and now we're going to be moving around to the left of the sound field, and then back to the front and up to the top, and then we're going to go down to the bottom. So that's right at the bottom. Okay, so we're going to pull back round to the front, and so we can just discuss a little bit more about what's going on here in our program. So you can see that I'm recording here, and if we scroll down a bit, you can see this is my mono mic that I'm recording So essentially, we've got a record of what's kind of happening with the stream exactly here. You can't see the screen over here, unfortunately, but that you can see the audio coming in there, and we're actually recording the stream there as well. So again, it's another test point in the stream, as well as being able to record over here. So what I'm gonna just quickly do here is I'm gonna run through a few of the things that I've got. So let's just come into Reaper and make this a little bit smaller. So you can see here we've got some encoders, which I'm going to switch off for the time being. So these are 16 channel tracks. So if I just open up a tone generator, it will put out tone equally on all 16 channels. Now that is good for us, so we can check that actually less of any encoding, that there is actually a set amount of signal going through the chain from one end to the other, and that there's no degradation across the 16 channels that we're transmitting. So we can do that with all of the 3 different types of noise, and then we've got stereo encoders, so we can check that our encoding is happening correctly through the broadcast chain. So what I'm going to quickly do now is I'm going to mute out the mic, my mic here, and then I'm just going to pop up some noise for each of the noises, and then I'm going to pan them around, and then we're going to come back up. All right. Now, as you can see, especially with that final kind of sine sweep, it's not a perfect system, and generating noise from the DAW and using that for actual kind of signal analysis, which isn't really what we're using it for here. We're just using it for generalized testing. It's not really that acceptable. Now, when I stop here, I wonder what's happening to the audio there. When I stop here, this final vlog. I'm actually going to be running some pre-recorded tests which I've got, which includes some Dolby calibrated pink noise and some more tone, but like some test tones which are certified test tones that we can run around the system. And that's a much more kind of scientific way of achieving analysis results, which essentially we're not too interested with at this point. So to wrap this all up, we have our DAW that's performing our third order ambisonics encoding. We have a template which allows us to do lots of testing, and we have a few record points in this that broadcasts the audio to or transmits the audio via Dante to OBS, where we're doing some muxing, and we're also recording. So we've got another kind of test point there, and then we're going from OBS to the server where we're also recording, and then we're creating the dash chunks to be live streams, or they are live. They are what will be viewed by the player when live streaming is happening. Now, this DAW and OBS configuration is where I see the software component in the future, and with a sufficiently powered machine, all of this could be run on a single machine, making for quite a nice tidy package, like an all-in-one box that everyone from professional broadcasters to just consumers, prosumers, people that are interested in getting in on this new kind of immersive streaming, they can use this to take their equipment and go live out to the world with it. So that concludes it. Thanks for watching.